This is my intermediate algebra course. Today we're going to continue to learn functions and function notation. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. In the previous class, we learned how to find the domain of a function. The domain is all of the possible inputs that you can put into a function that are able to produce an output. Remember, a function can be thought of as a machine that processes an input. A certain machine may not be able to process some inputs, and if the machine cannot process the input, then that input is not part of the domain. But all of the inputs that can be processed by the function are part of the domain of the function. So, to use the video game analogy, all of the buttons that you can push on the controller that produce a result on the screen are part of the domain. All those buttons that do something to your man on the screen or produce some sort of result, all those buttons are the domain of the function. And the function is the console with the video game. But today, we're going to learn how to find the range of a function. The range is all of the outputs of a function that are produced from the inputs in the domain. So if an input is in the domain and the function can process it, the output that is produced is part of the range. And we want to know all the numbers that are in the range, all the possible outputs that can be produced if you plug in a number from the domain. So the range is all the possible things that can happen on your video screen, your TV screen, as a result of pushing the buttons in the domain, using the video game as an analogy. So let's do a practice problem here. It says, find the domain and range of the function below. Now, we know how to find the domain of this function. We know that both 0 and negative numbers produce an undefined logarithmic expression. So the domain is all real numbers greater than 0. Those are the numbers that we can plug into x. If you plug in a negative number here for x, then the function is undefined. If you plug in 0, the function is undefined. So you the machine, the function, is not able to produce an output. It cannot process 0 or negative numbers. So 0 and negative numbers are not part of the domain. But all positive numbers, all numbers greater than 0, they are part of the domain. So it's very easy to find the domain given what we know about logarithmic functions. We learned this in the previous class. And here's set notation and interval notation for the domain. So it's not very difficult to find the domain of this function, but what you'll find is that determining the range is much more complicated. The range is all the possible outputs that are produced when you plug in x to this function. But if we try to find those outputs, you'll see that it's kind of tedious. If we plug in 3, well, we have to use a calculator to find log base 2 of 3. So that's a complication. If we plug in a number that we don't need a calculator to process, for example, 1/2, well, we still need to do some math in order to figure that out, and it may take a lot of time and energy to figure out what the pattern is that shows what exactly the range is. So it's not easy to find the range using algebra and calculating all different values, just plugging in x values. So what we're going to do is we're going to graph that function. So up here, the vertical axis is labeled f of x, but we're also going to call it y. I know that's kind of confusing. The horizontal axis is labeled x, of course. The input of the function is going to be the x value on this graph, the x value of each point, and the output is going to be the y value. So the input is the green, that's x is the green, and y is the output. So every one of these points on the graph has an input, which is the x value of the point, and an output, which is the y value of the point. And the reason that we label the vertical axis f of x is because, remember, f of x is the output. X is the input, f of x is the output. But just to make things easier, like I said, we're going to label it y also, because we're used to using y. So you can call the vertical axis log base 2 of x, because that's how you calculate the y value, or you can call it f of x or y. I know that's confusing, but we'll get into more of that as we go along here. Now, looking at this curve, we can see what the range is. The range is all the possible y values. First, let's look at the domain. Notice that there are no points over here. That's because x cannot be negative. If you have a point over here, for example, that would be negative 3, 2, but x cannot be negative. The inputs cannot be negative. So there's no points over there. So we can see, just looking at this graph, that the domain is all values greater than 0, all real numbers greater than 0, because the graph is in the second and fourth quadrants over here. So we can find the domain looking at the graph, but we can also find the range. As you can see, the graph keeps going down, 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 and it never stops. So any negative number is part of the range of the function. Because if you look at the points on the graph, down here, the points have negative y values that just get smaller and smaller. Also, you see this point, 1, 0, is on the graph. That means that 0, that's a y value of a point on this curve. So that's part of the range. All the y values on this graph are part of the range, and all the x values are part of the domain. That's how this works. So the y values just get bigger and bigger, and I know it's kind of hard to see, but this graph will just keep going up and up and up and up, and it'll never stop. So the y values can be negative numbers, 0, or they can be any positive number. So the graph shows that its points can have any y value that is positive, negative, or 0, and the y values increase or decrease indefinitely. So as you can see, if we analyze the graph, finding the range is pretty easy. So the range is all real numbers. Again, we're talking about the y values. The y values of the graph can be all real numbers. In set notation, we say all real numbers. In interval notation, we say negative infinity to infinity. But the important point here is that by analyzing the graph of a function, we can easily see the domain and the range. And that's what we're going to do today. So it says here, the graphs of various functions are written below. Write the domain and range of each function in words, set notation, and interval notation. So over here, notice that we have the graph of a function. It's this red segment here. The horizontal axis is labeled x, of course, and the vertical is labeled f of x, but we're also going to call it y. When finding the range of a function, we're going to use y instead of f of x, because it's tedious having to write f of x over and over again. So if you look at this graph, all the points on that segment have x values that are between 2 and 5. So if you look at all these green points on that red segment, all the points have x values that are between 2 and 5. So the domain is all real numbers between 2 and 5, but we have to say inclusive, because notice that these dots are filled in, which means that the x values of those points are in the domain. So 2 and 5 are also in the domain. That's what we mean by inclusive. So all the x values between 2 and 5, but also 2 and 5 are part of the domain. So again, we're talking about the horizontal, we're talking about the x values from 2 to 5. I went a little too far there. 2 to 5, the x values of the points go from 2 to 5. So in set notation, we say that the domain is the set of all x values such that x is between 2 and 5, but it includes 2 and 5 are also in the domain, so we have to write less than or equal to symbols. In interval notation, we use brackets, and we say 2, 5. That means that the domain is all of the values between 2 and 5, but the brackets tell us that also 2 and 5 are part of the domain. So we learn how to find the domain using algebra and just thinking about the logic of the various functions. But we can also see here that the graph shows us how to find the domain of a function. So now let's find the range. Again, the domain is all of the possible x values of the points on this graph. This point over here has an x value of -3. But that point is not on the graph. It has to be on this red segment. This is representative of the function. So -3 is not part of the domain because it's not on that red segment. Now, the y values of the points on this graph, they are part of the range. So what are all the y values of the points on that graph? Well, you can see that if we consider the vertical distance here, the y values of the points, they are all between -4 and -1. So the range is all real numbers between -4 and -1, but we have to say inclusive because these endpoints, they have filled in dots. So -1 is part of the range, and over here we have -4 is part of the range. So remember, the range is the y values, all the possible y values. Now, I should also mention, notice we say all real numbers. Remember, we learned that in the previous class. We have to say all real numbers. Why is that? Well, because imaginary and complex numbers, they are numbers. But we're not allowed to use imaginary or complex numbers as inputs or outputs of functions. Okay, so now let's write the range and set notation. The range is the set of all y values. Notice I use a y because now we're talking about range. Now technically it would be better to use f of x, but we don't want to have to write f of x over and over and over again. So instead we're just going to write y. That's how mathematicians traditionally do this. So the range is the set of all y values such that y is between -1 and -4. Actually, we have to start with -4. You want to start with the smallest number. That's the best way to do it. And we have to say less than or equal to. So we have to have less than or equal to symbols there. And the range in interval notation is a bracket and -4, -1, and then another bracket. Again, the brackets mean that -4 and -1, the endpoints, they're the y value of those endpoints, they're part of the range. Okay, let's do a couple more of these problems before you try one on your own. So, if you look at this graph here, we're going to find the domain. All of the x values of the points on that graph are between -6 and 7. So the domain is all real numbers between -6 and 7. So again, this point here, all these points have x values that are between -6 and 7. But notice the open dots at the ends. So we don't say inclusive because -6 is not part of the domain and 7 is not part of the domain, only the numbers in between. So in set notation we can say the domain is the set of all x values such that x is between -6 and 7, and we don't use less than or equal to symbols. We just use less than symbols. In interval notation we use parentheses. Why do we use parentheses instead of brackets? Because -6 and 7 are not part of the domain. Only the numbers in between -6 and 7. Okay, now we're going to find the range. The range is the y values of all these points. And if you look at the graph, we can see that the y values of all those points on that red curve are between -3 and 2. You see that? All the y values are between -3 and 2. So if you start from here and you go down, you see that they're all between -3 and 2. So the range is all real numbers between -3 and 2. In set notation, we say the range is the set of all y values such that y is between -3 and 2. So this point here is -2, -1. -1 is part of the range because it's between -3 and 2. This point here is the lowest point. This point here is the lowest point. It has a y value of -3. That's where we get the -3. And this point here has a y value of 2. That's where we get the 2. In interval notation, we use parentheses, -3, 2. Again, we use parentheses because -3 is not part of the range and 2 is not part of the range. So as you can see, this is pretty easy. You can probably do this very quickly. Now all the x values of the points on this graph are between -4 and -1. So the range is all real numbers between -4 and -1, but we have to say including -1 because there's a filled in dot at -1. The set notation tells us that the domain is a set of all real numbers, or excuse me, all x values such that x is between -4 and -1, but including -1, so we have to write a less than or equal to symbol there. And in interval notation we use a parenthesis, -4, comma, and then -1, and then a bracket. Why a bracket? Because again, -1 is in the domain. -4 is not in the domain, so we have to use a parenthesis. But all numbers between -4 and -1 are in the domain. Now, notice if we're going to find the range is all the y values of the points on this function. But all the points on that graph have the same y value, -5. So the only value in the range is -5. So in set notation, we say the range is the set of all y values. We use y because we're finding the domain, or excuse me, we're finding the range. The range is the set of all y values such that y is equal to -5. So the restriction on the range is that y must be equal to -5, which means it can only be one number. Now, interval notation is not really appropriate when you only have one value in a set of numbers, because you can't really have an interval when there's only one number. But if you had to write interval notation, we'd write bracket, -5, comma, -5, bracket, meaning that there is really no interval. If you write a number line and 5 or -5 is the only number, then there's no interval. If you had an interval, say -3 to -5, then there's space in between. There's an interval. That's what interval means. But because there's only one number, there is no space in between. So interval notation doesn't really make sense. But if you had to write interval notation, it would look like this, because there's nothing in between -5 and -5. But we use brackets because -5 is part of the range. So now it's time for you to try. Go ahead and attempt number 4. And when you come back, we'll do it together. Okay, we're back. The domain of the function is all real numbers between -3 and 1, including -3. So if you got that right, good job. The domain is the set of all x values such that x is between -3 and 1, including -3. So we need a less than or equal to symbol there. In interval notation, we need a bracket, -3, comma, 1, and then a parenthesis. So a parenthesis because we have an open dot, and a bracket because we have a closed dot. So that means that -3 is part of the domain. Everything in between -3 and 1 is part of the domain, but 1 is not part of the domain. So if you got that right, good job. The range is all real numbers between 3 and 5, including 3. So if you got that right, good job. The range is the set of all y values such that y is between 3 and 5, but including 3. So we need a less than or equal to symbol there. And set notation, we need a bracket, 3, and then comma, 5, and then a parenthesis, because 5 is not part of the range. So if you got that one right, excellent. Okay, go ahead and try number 5, and when you come back, we'll do it together. Okay, we're back. The domain of this function is all real numbers between 2 and 6 inclusive. So it's the set of all x values such that x is between 2 and 6, but inclusive means it can be 2 and 6 also, so we need less than or equal to symbols, 2 of them. And we need brackets, so 2 comma 6 with brackets for interval notation. So if you got that answer, excellent. The range is all real numbers between 1 and 4, inclusive. So it is the set of all y values such that y is between 1 and 4, and it can also be 1 and 4. So we need less than or equal to symbols. Remember, inclusive, see these inclusives here, that means that the endpoints are part of the domain and range. In interval notation, we use brackets, 1 comma 4. So if you got that one right, excellent. Okay. On to number 6. Now, with number 6, the range is going to be a little weird. Remember, you have to. There's only one value in the range. Remember, we had to write this interval notation here. -5 was the only number in the range, so we wrote this expression here. So you're going to have to deal with that in problem number 6. So try number 6. When you come back, we'll do it together. Alright, we're back. The domain of that function represented by the graph is all real numbers between -5 and 2. If we write the domain in set notation, it's the set of all x values such that x is between -5 and 2. And these are open dots here, so we don't need less than or equal to symbols, just less than symbols. And we need parentheses for interval notation, -5, comma 2. So if you got that one right, excellent. The only value in the range is 3. So the range in set notation is all y values such that y is equal to 3. That's the restriction on y, is it must be equal to 3. Now again, interval notation is not really appropriate in this example, but if we had to, we would say 3, 3 with brackets, meaning the only value in the range is 3 because all the points have y values of 3 and 3 only. So if you got that one right, excellent. Alright, let's do number 7 together. This is a little tricky. In all the previous problems, we figured out the domain and range by looking at the endpoints of the function. But in this problem, when we try to find the range, something different is going to happen. Notice that all the points on this graph have x values that are between 1 and 6. So the domain is all real numbers between 1 and 6, including 1, because there's a closed dot at x equals 1. So the domain is the set of all x values such that x is between 1 and 6, but including 1. So we need a less than or equal to symbol next to the 1. In interval notation, we use a bracket, number 1, comma 6 with a parenthesis. Now the range is where things get a little bit more complicated. The range is all the possible y values of the points on this graph. And we might be tempted to look at this point here and use that as the boundary for our y values. But this point does not have the smallest y value of all the points on that graph. This point here at this corner has the smallest y value. And so we say that the range is all real numbers between 0, because that corner point has a y value of 0. That's the smallest y value. All real numbers between 0 and 4, because this point up here has a y value of 4. That's the highest point. And all the points in between, all the y values of the points on the graph in between those points, the y values are all represented. For example, this point here does not have a y value of 2 because it's an open hole, but this point over here does have a y value of 2. So in set notation, we say that the range is the set of all y values such that y is between 0 and 4 inclusive. So we need less than or equal to symbols. Now this is an open dot over here, but we didn't use that point to find the range. We used this point. 5, 0 is on that graph, which means that 5 is part of the domain and 0 is part of the range. So 0 is the smallest number, so we use that number, and because 0 is part of the range, we have to say less than or equal to here. And we have to use the word inclusive, meaning that 0 and 4 are part of the range. And so let's write interval notation. We need brackets and 0, 4. So there you go. So that one was a little tricky because we didn't use this endpoint to figure out what the range was going to be. All the y values are between 0 and 4, if you look at this area here. Okay, on to number 8. Let's try number 8 together. Let's first find the domain. So all the points on that graph have x values that are between 0 and 5. So the domain is all real numbers between 0 and 5, but we have a closed dot at the right, so including 5. So the domain is the set of all x values such that x is between 0 and 5, but including 5. So we need a less than or equal to symbol on 5. And in interval notation, we use a parenthesis, 0, 5 with a bracket. So all of the x values go between 0 and 5, if you look at the x values of the points on that curve. Now the range is going to be a little bit harder to find because notice these endpoints, they're not really the boundaries in terms of the y value. The smallest y value is at this point here, and the biggest y value is at this point here, and all the numbers between those y values are represented on this graph. Here we have a hole, so it seems like 0 is not part of the range because y is 0 at that point, but we have points over here that do have y values of 0. So the range is all real numbers between -5 and +3. -5 and +3. Because those are the smallest and biggest y values of the points on that graph. And we say inclusive because these points don't have holes. So in set notation, we say that the range is the set of all y values such that y is between -5 and 3, and we use less than or equal to symbols because those points are part of the range. In interval notation, we use brackets, -5, 3. So there you go. So now it's time for you to try. Go ahead and attempt number 9. And when you come back, we'll do it together. Remember, finding the range is going to be a little tricky. Okay, we're back. So the domain is all real numbers between -4 and 4. So all the x values on that graph are between all the x values of the points on the graph are between -4 and 4. So in set notation, we say the domain is the set of all x values such that x is between -4 and 4. But we have open dots there, so -4 and 4 are not part of the domain. So we use parentheses in interval notation. And the range is going to be all real numbers between -5 and 1, including 1. And the reason for that is we want to find all the possible y values of the points on this graph. The y value of this point is the biggest y value of all those points, and it's 1. That's where we get this 1 here. And -5 is not in the range, but our values approach -5. That's the smallest they get. So in set notation, we say the set of all y values such that y is between -5 and 1, and we're going to include 1. Y cannot be -5 because that point is not actually on the graph. So that's why we write less than. But y can be 1 because that point is actually on the graph and its y value is 1. So that's where we get the less than or equal to symbol. So we use a parenthesis, -5, comma, and 1 with a bracket in our interval notation. So if you got that one right, good. And why don't you try number 10? You can take a picture of these problems if you want to help you. Go ahead and try number 10. When you come back, we'll do it together. Alright, we're back. The domain is all real numbers between -6 and 5 inclusive. It's the set of all x values such that x is between -6 and 5. And we need less than or equal to symbols because we have closed dots. In interval notation, we use brackets, -6, comma 5. So all the x values are between -6 and 5. All the x values are the points on that graph. The range is all real numbers between -6 and 0 inclusive. So if you look at all the points, the smallest y value is down here, and all these points, -6, and the highest, the biggest y value is not here on this point. The biggest y value is at this corner. So it's kind of confusing. And all of the points have y values in between those two max and minimum y values. So in set notation, we say the range is all, or the set of all y values such that y is between -6 and 0, and we have to say less than or equal to because these purple points, they're all on the graph. So we say inclusive. In set notation, we need brackets, -6, comma 0, and there you go. So some of these problems can be a little tricky. Okay, let's try number 11 together. In this problem, notice that we have an arrow. At the right, we have an arrow. That means that the graph goes in that general direction and just keeps going and going and going. It keeps going up and up and up, and it keeps going farther and farther to the right. So all of the x values of the points on this graph are greater than -4, and they just keep getting bigger and bigger and bigger. There's no bound in terms of how big those x values can get. So the domain is all real numbers greater than -4. It's the set of all x values such that x is greater than -4. But because it's a closed dot, or excuse me, it's a open dot, we say greater than, not greater than or equal to. Now in interval notation, we use a parenthesis, a -4. That means that -4 is not part of the domain, because that x value is not in the domain. But then because the graph keeps going on and on and on, we use an infinity symbol. And we never write a bracket on infinity because bracket means that this number is part of the the domain. The problem is infinity is not a number. So it's impossible for something to be equal to infinity. So we never write a bracket next to an infinity symbol. Okay, so now the range can be determined if we consider the fact that this graph just keeps going up and up and up and up. So the range is all real numbers greater than -3. Why -3? Well, because the y value of this point is the smallest y value near the points on the graph. Now it's not part of the range, but it gives us a bound. So the range is the set of all y values such that y is greater than -3. And in interval notation, we say -3, comma, infinity with parentheses. Okay, let's try another one of these problems. Now we can consider this graph to just be going off in the straight, the general direction that it shows here. That is kind of ambiguous, but so all the x values of the points on this graph, they're less than or equal to 1, 2, 3, 4, 5. So we don't have any values above 5, no x values above 5. All the x values are less than 5 or equal to 5. So the domain is all real numbers less than or equal to 5. In set notation, we say the domain is the set of all x values such that x is less than or equal to 5. In interval notation, we say we have a parenthesis and then -infinity, comma, 5, and then a bracket. So that means if we have an interval, we have 5 here, and our x values can be anything less than 5. Now notice that all the points on this graph have y values that are between 2 and 4. The points that have the biggest y values are these points up here at the top of those corners, and the points that have the smallest y values are the points at the bottom parts of those teeth, those corners, whatever you want to call them. So all the y values are between 2 and 4. We don't have any gaps in here, so all the y values in between those values are represented. So the range is all real numbers between 2 and 4 inclusive, because these points, that their y values are part of the range. So the range is the set of all y values such that y is between 2 and 4, and we need less than or equal to symbols. And we need brackets for interval notation, 2, comma, 4. So there you go. So again, the domain is all the possible x values of the points on the graph, and the range is all the possible y values of the points on the graph. Let's try one more of these before you try one on your own. All the x values on this graph are less than -1. This point has an x value of -1, but it's an open dot, so only x values less than -1 are on those points. So the domain is all real numbers less than -1. The set of all x values such that x is less than -1. And in interval notation, we say -infinity, comma, -1, and a parenthesis because it's an open dot. Now notice that all the points on that graph have the same y value. The only value in the range is 3, because all these points have y values of 3, and 3 only. So in set notation, we say that the range is the set of all y values such that y must be equal to 3. That's the restriction. Y can only be equal to 3. And interval notation is not really appropriate here, but if we had to write interval notation, we would say 3 comma 3 with brackets. All right. You can take a picture of all these problems here if you'd like. Now you're going to try number 14. That picture will help you with these problems. Try 14. When you come back, we'll do it together. All right, we're back. The domain of that function represented by the graph is all real numbers less than or equal to 4. It's the set of all x values such that x is less than or equal to 4. Interval notation, we need a parenthesis, negative infinity, comma, 4 with a bracket. So if you got that one right, good job. Okay, the range is all real numbers less than or equal to 5. Because the biggest y value is the y value of this point here, which is 5. And all the y values of the points down here are less than 5. So the range is the set of all y values such that y is less than or equal to 5. And we say negative infinity, comma 5, bracket, in interval notation. If you got that right, good job. Try number 15, and when you come back, we'll do it together. Okay, we're back. The domain of that function is all real numbers greater than 1. It's the set of all x values such that x must be greater than 1. And in interval notation, we say we use a parenthesis and then 1 and comma, infinity, and another parenthesis. All right, if you got that answer, good job. The range is all real numbers greater than or equal to 0. This point here has the smallest y value. This point here doesn't really tell us anything about the range. You might say, well, y cannot be equal to 3 because that's an open dot. Well, what about this point here? That point has a y value of 3, so the y values of the points on this graph are all greater than or equal to 0. So the range is the set of all y values such that y is greater than or equal to 0. I know it's kind of confusing because this point is not, it doesn't have the smallest y value. This point has the smallest y value. So we use brackets for interval notation, 0, comma, infinity, because it just keeps getting bigger and bigger. Remember, you never write a bracket on or next to infinity. It's always a parenthesis. So if you got that answer, good job. Try number 16. When you come back, we'll do it together. Okay, we're back. The domain is all real numbers greater than 1. So the set of all x values such that x is greater than 1. And in interval notation, we say 1 with a parenthesis to positive infinity. If you got that right, excellent. The range is negative 1. The only value in the range is negative 1. So in set notation, we say the range is the set of all y values such that y must be equal to negative 1. And in interval notation, we use brackets, and we say negative 1, comma, negative 1. So if you got that one right, excellent. All the points have y values of -1 and -1 only. All right, notice in this problem there's arrows on the left and the right. So the x values of the points on this graph can really be any real number. So we say that the domain is all real numbers. You can have an x value of -5, or an x value of 1, or an x value of -a billion that goes very far to the left. You can have any x value. Now, in this special situation, when the domain is all real numbers, remember in set notation we just use words also. We say all real numbers. And in interval notation we say -infinity, comma, infinity with parentheses. Because the graph goes to the left, the x values get smaller and smaller and smaller, and they just keep getting smaller and smaller, and when we go off to the right, the x values get bigger and bigger and bigger, and they never stop. Well, this graph is also going down, and over here it's going up, so we assume that it continues to go down, and it continues to go up at the right. So the range, the y values of the graph, can be any real number. And in set notation, of course, we say the same thing, all real numbers. And in interval notation, we again say -infinity to infinity. So let's try number 18. We have a similar situation here with the domain. We have arrows, meaning the graph continues to move to the left and to the right, which means that the domain is all real numbers. And for set notation, we say all real numbers in words in that special situation. And interval notation, -infinity to infinity. Now the range, we have to be careful with the range. The left part of the graph goes down, down, down. The right part goes down, down, down. It never stops. But the highest point is here. And so the biggest y value is 1, 2, 3, 4, 5. So the range is all real numbers less than or equal to 5. It's the set of all y values such that y is less than or equal to 5. Again, the range is all the y values of the points on the graph. In interval notation, we say -infinity, comma, 5, and we need a bracket on the 5 because 5 is a y value that is on that point, which is on the graph. Okay, now it's time for you to try. Try number 19. We'll have a similar problem there. When you come back, we'll do it together. Okay, we're back. So notice that the graph goes forever to the left and forever to the right. That's what those arrows mean. So the domain is all real numbers. And in that special situation, we write set notation in words. And in interval notation, of course, we have -infinity, comma, infinity with parentheses. Now the range is all real numbers greater than or equal to -4. In set notation, we say the set of all y values such that y is greater than or equal to -4. And that's because this point here has a y value of -4 and it's on the graph. We use a bracket, because -4 is part of the range, and then an infinity symbol. And remember, never put a bracket next to an infinity symbol, because infinity is not a number. It's impossible for something to equal infinity. Try number 20, and understand that this pattern is assumed to continue. The squiggly line just continues with the same in the same general pathway. So try 20. When you come back, we'll do it together. Okay, we're back. The domain of that function represented by the graph is all real numbers. And in set notation, of course, we say all real numbers. In interval notation, we say -infinity, comma, infinity. The range is all real numbers between -2 and 2 inclusive, because the points are limited to this region here, which means the y values have to be between -2 and 2. The y value of this point is 2, that's the highest point, and the y value of this point is -2, that's the lowest point. So this the range is the set of all y values such that y is between -2 and 2, but it can be equal to -2 and equal to 2 also. So you say less than or equal to. And we need brackets for our interval notation. So if you got that one right, good. All right, so let's try 21 together. Now we have kind of a gap in between here. All of the points in this region have x values that are less than -3, and all the points in this region have x values that are greater than 1. So we say that the domain, which is all the x values, is all real numbers less than -3 or greater than 1. In set notation, we say that the domain is the set of all x values such that x is less than -3, or, it's very important to use the word or, x is greater than 1. Now, why is it important to use the word or? If you use the word and, mathematicians interpret that to mean that x can be less than -3 and greater than 1 at the same time. If you draw a number line, you can see it's impossible for a number to be here and here at the same time. And means that they're in those regions at the same time. That's impossible. Or means, we use or because or means that the values can be here or they can be here, but not at the same time. I know you're probably thinking that that's not really necessary. That's overthinking it. But mathematicians, in this case, they like to be specific. But sometimes you'll see the word and or written without factoring in that logic in other contexts. So be aware of that. Okay, in interval notation, we say -infinity, comma, -3, and we have an open dot, so we have a parenthesis there, and then we have a union symbol, which means or. The x values can be in this region, or they can be in this region, which is 1, comma, infinity. So there you go. Let me write that union symbol. Now, all the y values of the points on this graph in this region are less than 1, and the y values of the points up here are greater than 4. So the range of the function is all real numbers less than 1 or greater than 4. It's the set of all y values such that y is less than 1 or y is greater than 4. Again, it's so important that you use the word or and not and. And means that y values can be less than 1 and greater than 4 at the same time. That's impossible. They can be either less than 1 or they can be greater than 4, but there is no such thing as a y value that is both of those things at the same time. Okay, in interval notation, we use negative infinity and then 1, and we have open dots there, so we're going to use a parenthesis on the 1, and then a union symbol, which means or, and then 4 comma positive infinity. We have an open dot up here, so we need a parenthesis there. Okay, let's try another one of these problems. Again, we're finding the domain and the range. All the x values of the points on the graph in this region are less than 2, and all the points on the graph in this region are greater than 4, or the x values are greater than 4. So the domain of that function is all real numbers less than 2. The x values of the points here are all less than 2, and the x values of the points here are greater than 4. So the domain is the set of all x values such that x is between, actually x is less than 2 or x is greater than 4. And in interval notation, we say negative infinity, comma 4, parenthesis, union symbol, parenthesis. Actually, that should be a 2, sorry. And then 4, comma infinity. Okay, so all the points on the graph in this region have y values that are less than negative 5, and all the points on this region have y values that are greater than 4. So the range is all real numbers less than negative 5 or greater than negative 4. In set notation, we say the range is the set of all y values such that y is less than negative 5 or y is greater than negative 4. And in interval notation, we say negative infinity to negative 5, or comma negative 5, and then the union symbol, and then negative 4, comma infinity. So now it's time for you to try one of those problems. Try 23, and when you come back, we'll do it together. Okay, we're back. The domain is all real numbers less than 1 or greater than 3. So it's the set of all x values such that x is less than 1 or x is greater than 3. So if you got that right, good job. In interval notation, we say negative infinity to 1, parenthesis, union symbol, 3, comma infinity. And there you go. So the range is all real numbers less than negative 2 or greater than 3. The range is a set of all y values such that y is less than negative 2 or y is greater than 3. In interval notation, we say negative infinity, comma negative 2, parenthesis, union symbol, parenthesis, 3, comma, infinity. Okay, go ahead and try 24, and when you come back, we'll do it together. All right, we're back. The domain is all real numbers less than 1 or greater than 2. It's the set of all x values such that x is less than 1 or x is greater than 2. In interval notation, we write negative infinity, comma 1, parenthesis, union symbol, parenthesis, 2, comma, positive infinity, parenthesis. If you got that right, good job. The range is all real numbers less than negative 2 or greater than 2. It's the set of all y values such that y is less than negative 2 or y is greater than 2. And in interval notation, we say negative infinity to negative 2, parenthesis, union symbol, parenthesis, 2, comma, infinity. So if you got that one right, excellent. Okay, let's try number 25 together. Notice that the points on this graph have pretty much any x value. We go to the left indefinitely, and we go to the right indefinitely. But there's one point here that's an open dot, which means that x cannot be equal to 1, 2, 3, 4. X cannot be equal to 4. So we say that the domain is all real numbers except 4. So the domain is the set of all x values such that x is not equal to 4. So what that means is x can be anything other than 4. In interval notation, we say negative infinity, comma, 4, parenthesis, union, parenthesis, 4, comma, positive infinity. So as you can see, it's a lot easier to write in words or in set notation than to write the domain in interval notation in this particular case. Or maybe this is easier, it just depends on the symbols that you prefer to use. Now, all the points on this line have the same y value. Remember, the range is all the y values, so the only value in the range is negative 2. So the range is the set of all y values such that y is equal to negative 2. It has to be equal to negative 2. And in interval notation, well, interval notation is not really useful here, but we just say negative 2 to negative 2, or negative 2 comma negative 2, and we use brackets. Let's try another one of those problems. All the points here have pretty much any x value, except we have a hole here, so x cannot be equal to 1, 2, 3, negative 3, and x cannot be equal to positive 1. So we say that the domain is all real numbers except negative 3 or 1. So it's the set of all x values such that x is not equal to negative 3. In this case, and would probably be more appropriate. In interval notation, we say, or we write negative infinity to negative 3, parenthesis, union symbol, negative 3, comma 1, and a union symbol. So there's a lot of intervals here that we have to right. And then 1 comma infinity. So we had 3 intervals there. 1, 2, 3. So interval notation is pretty useful in that case. Now, all of the y values of these points are pretty much represented. You might say, well, y cannot be equal to 1 because that's an open dot there. But we have a point over here that has a y value of 1. So 1 is actually part of the range. But down here, you see that that point has a y value of -3, but it's an open dot. So -3 is not part of the range, but any number bigger than -3 is part of the range, because again, the range is the y values of those points. So the range is all real numbers greater than -3. The set of all y values such that y is greater than -3. In interval notation, we say we write parenthesis -infinity, actually parenthesis -3, comma positive infinity, parenthesis. All right, why don't you try number 27, and when you come back, we'll do it together. Okay, we're back. The domain is it's all real numbers except 2. It's the set of all x values such that x is not equal to 2. And in interval notation, we write -infinity to 2, parenthesis, union, parenthesis, 2, comma, positive infinity. So if you got that right, excellent. The range is all real numbers, because the graph just keeps going down, 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 and up, up, up. So the y values of the points can be anything. Now you might say, well, what about this point? Y cannot be equal to 3, because that's an open dot. But look over here. There's a point over here that has a y value of 3. So that's actually, 3 isn't included in the range. In this special situation, remember, again, for set notation, we just write in words all real numbers. For interval notation, we write -infinity, comma, infinity with parentheses. So if you got that one right, excellent. Try number 28. When you come back, we'll do it together. Okay, we're back. The domain is all real numbers except 2 or 5. Now, you can write an and or an or, and in this case, maybe an and would be better. But again, most teachers and mathematicians don't really think about it in that much detail, so it probably doesn't matter if you write an and or an or. I know that's kind of confusing. In some situations it matters, in other situations it doesn't. Here you're just giving a list of numbers, so it doesn't really matter. Set notation, we say the domain is the set of all x values such that x is not equal to 2 and x is not equal to 5. The reason that and is probably better is because x has to be not equal to 5 and not equal to 2 at the same time. So and is used when both those things have to be true at the same time. And it is possible for a number to not be 2 and not be 5 at the same time. But again, don't worry about that. It's not really that important. The important thing is that we know that x cannot be equal to those two numbers. In interval notation, we write -infinity, comma 2, parenthesis, union symbol, parenthesis, 2, comma 5, parenthesis, union symbol, parenthesis, 5, comma infinity. All right, so if you got that one, good job. The range is all real numbers greater than or equal to -2. Now, you might say, oh, wait a second. These points have y values that are not part of the range because they're open dots. But what about all these points? They have the same y values. So actually, it's kind of a tricky problem. The range is the set of all y values such that y is greater than or equal to -2, because the smallest y value is on this point here. That's -2, and any y value greater than -2 is on those points. In interval notation, we write -2, comma, infinity. And we also need a bracket, not a parenthesis, but a bracket on that -2. So have you got that one right? Excellent. All right, so now we have asymptotes. Remember, an asymptote is an invisible line that your graph approaches. And asymptotes are very useful when graphing a function or a relation, but they're also useful when determining the domain and range. Now, it's impossible for the graph of a function to pass through a vertical asymptote. That will never happen, or else the equation would not be defined as a function. That's just a necessary requirement for functions. We learned that in previous classes. So that means that the domain is all real numbers except 2. X cannot be equal to 2 because there are no points. The graph doesn't go through that vertical invisible line. So there's no points with an x value of 2. But as you can see, the graph goes off to the right and it goes off to the left and it never stops. So all real numbers except 2. The domain is a set of all x values such that x is not equal to 2. And in interval notation, we write a parenthesis, -infinity, comma, 2, parenthesis, union, parenthesis, 2, comma, infinity. Now, we see that we have a horizontal asymptote, and in previous classes, we never had a graph actually pass through a horizontal asymptote, but it is actually possible for a graph to go through a horizontal asymptote. It doesn't always do that. The asymptote exists, first of all, because the graph is approaching this dotted line as it goes to the left. But as you can see over here, the graph actually passes through the horizontal asymptote. If this part of the graph were not here, then the range would be all real numbers greater than 1. But because we have this part of the graph here, the graph goes down forever, and we can see it obviously goes up and up and up and never stops. So that means that the range is actually all real numbers. So that was kind of a tricky one. And in interval notation, we write -infinity, comma, infinity with parentheses. So the difference with these problems is we have these asymptotes. Again, an asymptote is an invisible line that your graph approaches. Now, notice we have these vertical asymptotes, so that means that x cannot be equal to 1, 2, 3, 4. X cannot be equal to -4, and x cannot be equal to 3. So the domain is all real numbers except -4 or 3. It looks like we have the graph in all the other parts of the window. So the domain is a set of all x values such that x cannot be equal to -4 and x cannot be equal to 3. It is possible for both those things to be true at the same time, so we can use the word and. And up here again I wrote or. It probably doesn't matter if you write or and, but probably better to write and. But again, in words, nobody's really going to care if you use or and. Down here, mathematicians pay more attention to the words that you use. But even down here, it probably doesn't matter in that case. So for interval notation, we write parenthesis, negative infinity, comma, -4, parenthesis, union symbol, -4, parenthesis, -4, comma, 3, parenthesis, union symbol, parenthesis, 3, comma, positive infinity. Okay, now you see this horizontal asymptote. It looks like the graph, the red curve, does not pass through it. Now over here it approaches that horizontal asymptote, and it approaches here, and it approaches over here. So it approaches from the top and it approaches from the bottom, but there's no points on the horizontal asymptote. The red curve does not actually go through the horizontal asymptote. So it looks like the range can be any real number except -2. Because again, in order for -2 to be part of the group of y values on the graph would actually have to pass through that horizontal asymptote. So in set notation we say the range is the set of all y values such that y is not equal to -2. And in interval notation we write parenthesis, negative infinity, -2, and parenthesis, union, parenthesis, -2, comma, positive infinity. Okay, so now it's time for you to try attempt number 31. When you come back, we'll do it together. Okay, we're back. The domain is all real numbers except -3. So if you got that right, good job. It's the set of all x values such that x is not equal to -3. And in interval notation, we write negative infinity, comma -3, and you get the point. Alright, and the range is all real numbers except -3. So the set of all y values such that y is not equal to -3. And in interval notation, negative infinity, comma, -3, union, -3, comma, positive infinity. So if you got that right, excellent. All right, on to number 32. Go ahead and try 32, and when you come back, we'll do it together. Okay, we're back. The domain is all real numbers except -5 or 2. Now again, it's probably best to write and rather than or. Set notation, we write the set of all x values such that x is not equal to -5 and x is not equal to 2. In interval notation, we write negative infinity, comma, -5, union, -5, comma, 2, union, 2, comma, positive infinity. So if you got that one right, excellent. Now the range is actually all real numbers. we have a horizontal asymptote, but the graph actually passes through the horizontal asymptote. You can see that the points on the graph have y values that can be pretty much anything. There are no restrictions. So the range is the set of all y values. Actually, since it's all real numbers, remember we just write all real numbers for set notation. And in interval notation, we write negative infinity, comma, infinity with parentheses. All right, so if you got that one, good job. On to number 33. Let's try number 33. This is kind of a trick problem. It looks like we have some open dots there, some holes, but it turns out that this point here kind of fills the hole, and this point kind of fills the hole. So the domain is actually all real numbers, because the arrows go to the left and right, and we thought that x could not be negative 3, but it turns out there is a point where x is negative 3, and we thought that x could not be 4, but there is a point up here where x is 4. So the domain is all real numbers. And we write negative infinity, comma, infinity for set or interval notation. Now the range is all the y values. So we have negative 1 is the y value of all those points, and positive 3 is the y value of all those points, and positive 5 is the y value of that point. So what that means is there's only 3 values in the range. The only numbers in the range are negative 1, 3, and 5. You can use the word numbers or values, doesn't really matter. In set notation, we say the range is the set of all y values such that y must be equal to negative 1, and I'm just going to use commas, negative 1, 3, or 5. Now you have to use or because it's not possible to be negative 1, 3, and 5 at the same time. So in this case, it's very important to use the word or. If you write and, then you mean that y can be all those numbers at the same time. In interval notation, we write brackets, negative 1, comma, negative 1, then a union, 3, comma, 3, then union, 5, comma, 5. So again, interval notation is really not the best notation to use in that context. Alright, let's try a couple more of these before you try one on your own. Now, there's kind of a trick here. We have holes, but we do have a dot that kind of fills in those holes in a way. Over here we have 2 holes, but no dot that really fills them in. So the only x value that's not represented on the graph is negative 4, because the x value of the points that would be there are negative 4. So the domain is a set of all x values such that x is not equal to negative 4. In interval notation, we write negative infinity to negative 4, union, negative 4, comma, infinity. So it's kind of a tricky problem. Now, the range can be negative 5, because these points all have negative 5. The range can be also anything between negative 3 and 4. So the range is negative 5 or all real numbers between negative 3 and 4, including negative 3. Because these points do have y values of 3, but or negative 3, but up here, this point, there are no y values on the graph that have that are 4. So in set notation, we say the range is the set of all y values such that y is equal to -5 or y is between -3 and 4, including -3. So we need a less than or equal to symbol next to -3. In interval notation, we say we have brackets -5, comma -5, union symbol, bracket -3, comma 4, and then a parenthesis. So again, that's kind of a challenge problem there. And sorry about these. I don't know, my computer's having trouble with that. So let's try one more of these before you try one on your own. Now we just have 4 dots. So if you look at the x values of those dots, the x values are -3, 2, 3, and 4. So those are the only values in the domain. So the domain is the set of all x values such that x is equal to -3, 2, 3, or 4. The x values can't be those numbers all at the same time, so you have to say or. Now in interval notation, again, it's not appropriate to use interval notation, but if you had to, we would say -3, comma -3 with brackets, union, 2, comma 2 with brackets, union, 3, comma 3, and you get the idea. Okay, and the range is all the y values of those points. So the only values in the range are 4, 5, and 6, because those are the y values of those points. So in set notation, we say the range is the set of all y values such that y is equal to 4, 5, or 6. Not and 6, because y can't be 4, 5, and 6 at the same time. Now this is just listing numbers. Okay, so it's okay to use and. You're just listing the numbers. But here you're giving restrictions on the range. So y cannot be equal to 4, 5, and 6 at the same time. Again, it's really not something that is that important in this context. But it's probably best to say or when you're writing the set notation. In interval notation, we write 4, comma 4 in brackets, union, 5, comma 5 in brackets, union, 6, comma 6. All right, now time for you to try. We have 3 more problems today. Try number 36. These are the tricky problems. When you come back, we'll do it together. All right, we're back. So the domain is all real numbers except 3. The set of all x values such that x cannot be equal to 3. Interval notation, -infinity, comma 3, union, 3, comma positive infinity. It looks like x cannot be -2, because that's the x value at this point, but this hole has an x value of -2. Or excuse me, that point is on top of the hole. It has an x value of -2. So if you got that right, good job. The range is all real numbers greater than or equal to -5. Now you might say, well, this point is a hole, so y cannot be equal to -3. But we have a point over here where y is equal to -3. And you might say, well, y cannot be equal to 1, because the y value of that point is 1, but over here we do have y values of 1. So the range is the set of all y values such that y is greater than or equal to negative 5. And why negative 5? Because that's the lowest point here. And this point here is on the graph, so negative 5 is part of the range. And in interval notation, we say negative 5 with a bracket. We've got to make sure to write a bracket there. And then comma, positive infinity. So if you got that answer, excellent. Try number 37. When you come back, we'll do it together. All right, we're back. The domain is all real numbers. So this was kind of a tricky problem. It looks like x equals 1. The x value of that point is 1, but it's a whole, so it looks like x equals 1 is not going to be part of the domain, but this point down here has a value of 1. This point is part of the function. So it turns out that the domain is all real numbers, negative infinity, comma, infinity. The range is negative 5 and 2. Those are the numbers in the range. In set notation, we say the set of all y values such that y is equal to negative 5 or y is equal to 2. You can't say and because it's not possible for y to be negative 5 and 2 at the same time. Okay, in interval notation, we use brackets, negative 5, comma, negative 5, union symbol, 2, comma, 2. So if you got that answer, excellent. All right, let's do one more problem, then we'll be done for the days, until you do your homework, that is. Try number 38. When you come back, we'll do it together. All right, we're back. So the only values in the domain are negative 3, 0, and 6. So the domain is the set of all x values such that x is equal to negative 3, 0, or 6. Very important to say or. All we have is just dots. So the x values of those dots, which are negative 3, 0, and 6, are the domain. In interval notation, we would use brackets, negative 3, comma, negative 3, union 0, comma 0, union 6, comma 6, using brackets. So if you got that right, excellent. The range is the y values of those points. There's 3 points, so 3 y values, negative 2, 2, and 4. So the range is the set of all y values such that y is equal to negative 2, 2, or 4. You have to say or. Now up here you're just listing numbers, so you can say and. But down here you're saying that y has to be equal to those numbers, but it can't be equal to all of them at the same time, so you have to say or. In interval notation, bracket, negative 2, end bracket, union, bracket, 2, comma 2, union, 4, comma 4. So if you got that answer, excellent. All right, that was the class today. If you'd like to take screenshots of all the work that we did today to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and number 2 and number 3 and number 4 and number 5 and number 6 and number 7 number 8, and number 9, and number 10, and number 11. But don't go before you get your homework. Let's take a look at the homework. Here's screenshot number 1 of the homework, and screenshot number 2, and number 3, and number 4, and number 5, and number 6. But don't go before you get the answers. Let's take a look at the answers. Here's screenshot number 1, and number 2, and number 3, and number 4, and number 5, and number 6. So remember, if you don't do that homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.